Again, all of our discussions now, as I have mentioned last time, are building blocks that we have to understand so that later on we can easily breeze through the logic of null hypothesis testing. Right? So last time we talked about the normal distribution. Okay, so let's just give a short recap of what we have discussed so far. So we talked about the normal distribution as some kind of non-existent though theoretical distribution of scores. And so the assumption is that when we collect data for a particular variable from the population, that data would form in a certain shape. No, and that is what we call as the normal distribution. And conveniently, we simply, or we can sort of describe the normal distribution as a distribution of scores wherein most of the scores are found here at the center, surrounding the mean of the distribution or the average value. And then there are fewer and fewer scores that are extremely high, and then fewer and fewer scores that are extremely low. No? So we can imagine all of these as containing raw score values, no? Numerical values. And we can see that there's a swelling in the middle to indicate that there are more values that can be found in this particular range, and that there are fewer and fewer values here and fewer values dito on the values below the mean. Okay. And then we also talked about locating the position of any given score within the distribution. And thus, we talked about z-scores. No? So any given score may, for example, have a z-score of 1.5, now, which tells us that that particular score is found somewhere around here relative to the other scores. No? Or if, let's say, for example, a given raw score, when we compute for its z-score, we found that the z-score is -2, then we can assume that that particular raw score is found somewhere here. No? Dito sa may -2 standard deviation below the mean mark. So these are your z-score values. So any given raw score, we can identify where they are located in the normal curve by simply computing for their z-scores. And another particular value of that is that if we know, let's say, for example, the z-score of a given raw score, the z-score of that raw score is +1, we can make statements or assumptions about the proportions, probabilities, and percentages of scores relative to this given raw score. So we can, using the table of normal distribution, we can make statements about the percentages of scores that are higher than that given raw score, or the proportion of scores relative to the whole above such. Same thing here, we can also talk about the percentages of scores that are below that raw score, or the proportion of scores relative to the entire distribution of scores that are below such. No? And most importantly, we can also talk about probabilities. No? So if we ask questions such as what is the probability of randomly drawing a score that is higher than this raw score, then this has an equivalent probability, which numerically is the same as the proportion value. If we ask what is the probability of randomly drawing a value lower than this raw score, then we can also estimate, or we can also determine that probability, which is numerically similar to the value of this particular proportion of the entire distribution. So those things can be done with our knowledge of the normal distribution and z-scores. So far, that's what we have discussed last time. Now, one of the reasons why we discussed about the normal distribution and z-scores is because such knowledge also applies to the more relevant topic that sort of scaffolds our later discussion about null hypothesis testing, which is sampling distribution. Okay, so what is sampling distribution? So let me read first its definition. It is the estimated, so again, it's estimated, it doesn't really exist. Now we assume it. It is the estimated distribution of, take note of this, of sample means, right? Now, so when we were talking about the normal distribution in our past discussions, all along, the distribution that we were referring to were the distribution of scores, right? Of raw scores. No. But this time, we're no longer talking about the distribution of raw scores. We're talking about the distribution of sample means. No? So what is a sample mean? So if this is your population, and then from your population, you have a sample and you compute it for the average value of a given variable, no, from this particular sample, that mean is a sample mean. So if you do that for a number of times, you collected multiple samples now from the population. And from each of these samples, you have a mean. Then you have a collection of sample means. And those sample means also forms a distribution, just like raw scores. No? And that is what you refer to as a sampling distribution. Meron ditong caveat, no? If an infinite number of sample means were taken. So what do you mean by infinite number? So parang hypothetically, if I draw an endless number of sample means, which of course is impossible, right? No. So hypothetically, if we do that, then what we will have, or the distribution of those sample means, would be referred to as a sampling distribution. Ang sabi dito, with larger sample sizes, sampling distributions are expected to be normal, no, because of the central limit theorem. No. And that's why when we talk about assumptions in statistics, oftentimes one assumption that is mentioned in textbooks is normality of the distribution, normality. However, when we talk about normality, we're not really referring to the normality of the distribution of the data. No. What we are referring to is the normality of the sampling distribution. And we can assume that the shape of the sampling distribution is normal when we have a larger sample size. No? So you might be wondering, why is it that when we do research, ang parating hinahanap ng mga teachers or ng mga instructors ninyo or ng advice ninyo is a larger sample size? So that's the logic behind this. No? So the logic is that with larger sample size, it guarantees a sampling distribution that is normal. So yun talaga ang requirement, no? Not necessarily your data being perfectly normal. I think some of you have asked before when we were discussing about normal distribution, may nagtanong, is it a bad thing if your data is not normally distributed? Not necessarily, no. Kasi ang mahalaga naman is a normal sampling distribution. So ito yung ini-illustrate ko kanina, no. So if you have a population, and then you took multiple samples, no, from the population, each of this sample would have a different mean. Hindi naman pwedeng pare-pareho yung mean na yan, no. And if you plot all of these means, no, 3, 4, 2, 3, 1, 4, 3, 5, 2, in a distribution, this is what your sampling distribution would look like. I have here some sort of an animation to better illustrate what I am discussing. So here is a simulator. So these are some information about the population. We're not exactly sure what this variable is, no, but apparently the average value at the level of the population is 50 with a standard deviation of 20 na nakalagay dyan. No? And then if we collect a sample of 20 participants, no, from the population. So let me do that now. So I'll click on take a sample. So if I take a sample, Ayan. No? So you can see, itong mga blue circles na to, ito yung data set mo. No? So ito ay 30. So kita nyo merong mataas na score, merong sobrang baba na score. Karamihan sa mga scores ay nandito. And then if you take the average of all of these, nandun yung average. Yan, that little green dot over there, that's the average. No? So what is the value of the mean? So ito, 45.814, standard deviation of 19.047. So kita natin, so ito yung mean ng population. So it's slightly below the mean of the population, no? For this particular sample. If I take another sample, all right, so this is a different sample now. Ito naman yung data set niya, itong mga blue dots. At ano ang average niyan? 43.79. So mas mababa pa. So this one, ito meron dark green dot dito. I'll take another sample, hypothetical sample. All right, ito naman yung data set niya. Ang kanyang value ay, malapit sa mean. No? So 50.062. So it's right there. No? This green, dark green dot. No? Now, if I do this, so I hope that you can imagine what we're doing. So from the population, right now, I've already drawn 3 samples. In each sample, iba yung mean. No? Nag-umpisa sa 45, naging 43 yung mean, na naging 50 yung mean. So every time we draw a sample, we would expect that the mean will be slightly different. Malapit doon sa mean of the population, which is 50. But some of them would be greater, some of them would be lower, and many of them would be close to 50. If I take another sample, ito naman yung data set ng 4th sample natin, ang mean ay 46.32. No? So nandito siya. Okay. Now, if I do this continuously, so we are now taking sample after sample, and these are the means of the samples that the program is continuously taking. So focus your attention here. Dito sa ilalim, itong nag-accumulate na sample means. All right, focus your attention there. So itong nag-accumulate na sample means na to, this is your sampling distribution. And notice, closely as it accumulates, what kind of shape it is forming. Okay. So medyo mabagal yung pag-take ng sample. Nakakailang samples na ba tayo? 37. So you can look at here, no. Ito yung count, no. So 41, 42nd sample, 43rd, 44th, 45th. Okay. So if we wait long enough, okay, sige. Maghintay tayo ng mga 1 minute. So itong nag-accumulate na ito, no, this is your sampling distribution. At ang sabi sa definition, if we have this run through infinitely, no, walang katapusan, the shape of this sampling distribution would be normal, no, for as long as the sample size that we have decided is large enough, no. 30, okay naman na yan, no. Of course, the larger the sample size, the more confident we are that we will have a normal sampling distribution. Okay. Yeah. So nag-accumulate yung mga means. All right, stop na natin. So this, what you're seeing right now, this is what is referred to as a sampling distribution. Again, the notion is that if your sample size is large, no, so each one of these sample means come from a sample size of 30. No? So the assumption is that it will form the shape of a normal distribution, which right now kita natin medyo normal naman na siya. No? But if we let this run continuously, it will be more become more and more normalized, no, in shape. Let's let it run in the background and we'll see how it looks like in a while. So that's the concept of a sampling distribution. Now, question. Sa palagi ninyo, itong mga means na ito, if we allow this to continue, no, if we take all of these sample means and we get the average of all of these means, the mean of all of these means, inadd mo lahat ng mga mean values, you divide it by, the number of samples you have taken, what do you think will be the value of that? What do you think will be the value of the mean of means, of the average of all of these sample means? Which we really can't do, right? No, kasi ang sabi sa definition, if an infinite number, we cannot wait for infinity, no, para matapos, no. But what is the assumption? What would be the mean of all of these means? Anyone who'd like to take a guess? The assumption is that the mean of the means, at kita nyo naman, no, ang center value pa rin ng distribution nito ay 50 pa rin. No? Kita naman dyan, right? So the assumption is that the average of all of these sample means would be the same as the average of the population. So you can see here, you will notice in here that the average value in the population is 3. We get multiple samples, no, from the population. Each of these samples meron siyang average value, no, ito yung average ng apat, no, and it formed this distribution, and the mean ang nasa gitna pa rin, the mean of this particular distribution is still 3 pa din. So the mean of the sampling distribution is expected to be the same, exactly the same as the mean of the population. So kanina sabi ko, regardless of the shape of the population, so you can see here, iba-ibang shape, no? Even if your population is normally distributed, your population is skewed, your population has a uniform distribution, an irregular distribution, for as long as you have a large enough sample size, you will notice that the sampling distribution remains to be normal, 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 or at least no, close to normal. So that is the assumption. Okay, so regardless, so hindi masyadong mahalaga yung shape ng distribution ng population. Ang mahalaga is that the sampling distribution is normal. And we can guarantee that, no, by increasing our sample size. And that's why in research, no, favored yung mga studies na malaki ang sample sizes. Now, the thing about the sampling distribution is that itong sampling distribution na to, ano ang content nito? Ang content nito ay sample means. So dati, ang pinag-uusapan natin, ang content ng distribution ay raw scores, no? Pero this time, ang content nito ay sample means. And whatever we've learned when we were talking about, normal distribution of raw scores, that's also applicable to a sampling distribution. So meaning to say, if I take one particular sample mean, I can also compute for its z-score, right? I can locate a sample mean. Let's say, for example, I located it here, 1.05, for example, or 1.3, for example, positive 1.3. So I can say that that particular sample mean relative to the other sample means now found in the distribution is around 1.3 standard deviations above the measure of central tendency, which is the mean of means, which is the population mean. Okay. So you can also do that. No? And as much as you can do that, you can also do the things that we did before, such as identifying, for example, what is the proportion of sample means that are greater than this given sample mean, no? The or the percentage, no? The percentage of sample means that are lower than a given sample mean, no, right here. And we can also talk about the same probabilities. No, what is the probability that if a certain random sample mean was drawn, what is the probability that it will be greater than a given sample mean? Or the probability of randomly drawing a sample mean that is lower than our specified sample mean. So things such as probabilities, percentages, and proportions, we can still also discuss that now when we're discussing about a sampling distribution or the distribution of sample means. And that really is sort of the backbone of null hypothesis testing now, as you will see later on.